When a program needs to store data, it opens a file. The mode string tells the operating system how the file will be used. W-write mode. If the file already exists, its contents are cleared, truncated before anything is written. If the file does not exist, a new empty file is created. This mode works with text data because Python assumes you will write strings. WT-write text mode. It is identical to W but makes the intention explicit. You will write text, Unicode strings. Under the hood, Python opens the file with a text wrapper that handles encoding, default UTF-8. WB-write binary mode. Here the file is opened for raw bytes. No encoding or newline translation is performed. You must provide bytes objects, for example, be hello. This mode is used for images, executables, or any data that must stay exactly the same. Analogy: think of a whiteboard. Opening with W or WT is like wiping the board clean and then writing new words. Opening with WB is like placing a pre-printed poster on the board. You cannot change the letters, you only stick the whole poster as is. Write and write lines are two different ways to send data to an open file object. Write takes a single string or bytes in binary mode and writes it exactly as given. You have to add any line break characters yourself if you want separate lines. Example, f.write line 1. WriteLines expects an iterable such as a list, tuple, or generator where each element is a string or bytes. It writes each element one after another without inserting extra newlines. Therefore, you usually prepare the list with line terminators already included. For example, lines equals list of first \n and second \n, f.WriteLines lines. Think of a conveyor belt. Write puts a single box on the belt. You decide its size and whether it has a label newline. WriteLines loads a whole series of pre-packed boxes. The belt just moves them forward unchanged. When to use which? Use write for occasional or dynamically built strings. Use WriteLines when you already have a collection of ready-made lines. It avoids a loop and can be slightly faster. !A, which stands for append, and a plus, which stands for append plus read, change the way new data is added to an existing file. A opens the file for writing only and positions the file pointer at the end of the file. Every write function call adds bytes after the current content. Previous data is never overwritten. If the file does not exist, it is created empty first. A plus opens the file for reading and writing. The file pointer starts at the end like a, but you can later seek function to any position and read the existing content. This mode is handy when you need to inspect the old data before deciding what to append. Overwriting versus extending. In W mode, the file is truncated, so the old content disappears. Think of erasing a chalkboard. In A or a plus, you are extending the board by writing on the blank space after the last line. Nothing you wrote earlier is removed. Real-world example, a log file for a web server. Each request is appended, with openaccess.log in append mode as log.write formatted string with time and URL newline. The old entries stay untouched. Newline characters tell the operating system where one line ends and the next begins. \n line feed used by Unix, Linux, macOS since OS X. \r\n carriage return plus line feed CRLF used by Windows. When you open a file in text mode WWT a plus, Python performs newline translation automatically. It converts every \, and you write into the platform's native line ending, and when you read, it does the reverse. This means you can always write \n in your code and let Python handle the rest. If you open a file in binary mode WB ob, no translation occurs. The bytes are written exactly as you supplied. This is useful when you need precise control. For example, generating a file that must contain Windows-style line endings on a Linux machine. Practical tip: always write \n in your strings, even on Windows. Only use binary mode if you deliberately need to store \r\n or other custom separators. When you call write, the data is first placed in an in-memory buffer rather than being sent straight to the disk. This buffering improves performance because disk I/O is slow. Automatic flushing: the buffer is flushed, written out when it becomes full when the file is closed or when the program ends. Explicit flush: if you need the data to appear on the disk immediately, for example after writing a critical log entry before a crash, call f.flush. This forces Python to push the buffer to the operating system. os.fsync: Even after flush, the operating system may still keep data in its own cache. OS.fsync of f.fileno asks the operating system to flush its cache to the physical device, giving the highest safety guarantee. Proper closing a file automatically flushes the buffer and releases the file descriptor. Forgetting to close can lead to data loss or file descriptor leaked errors. Using a with statement with open as f guarantees that close is called even if an exception occurs. Analogy: think of a mailbox, the buffer. You can drop letters into it all day. The postal worker only picks them up when the box is full or at closing time. Flush is like ringing the bell to tell the worker to collect the mail right now. Close is the final lock that makes sure no letters are left behind. Explanation: file operations can raise several exceptions. A robust program wraps the whole write/append sequence in a try except finally or uses with try : four spaces f equals open parenthesis single quote data.txt single quote comma single quote a single quote close parenthesis. May raise OS error if path is invalid. Four spaces f.write open parenthesis single quote hello backslash and single quote close parenthesis. May raise OS error if disk is full. Four spaces f.flush open parenthesis close parenthesis. May raise OS error on hardware error. Except OS error as e:. Four spaces print open parenthesis f string single quote file error space curly e.strerror close curly single quote close parenthesis. Finally colons. Four spaces if single quote f single quote in locals open parenthesis close parenthesis colon. Eight spaces f dot close open parenthesis close parenthesis ensures buffer is flushed. Common error codes available in Urano colons. Urano.enoent open parenthesis 2 close parenthesis. No such file or directory happens when the directory part does not exist. Urano.eaccs open parenthesis 13 close parenthesis. Permission denied, read-only file system or insufficient writes. Urano.enospc open parenthesis 28 close parenthesis. No space left on device, disk full. Urano.einval open parenthesis 22 close parenthesis. Invalid argument. For example, using a text mode file descriptor with binary data. Using with open ... as f simplifies the pattern, because the context manager automatically calls close even if an exception bubbles up. These are the kinds of questions that appear on exams for introductory programming courses. What happens if the file does not exist? In W or a mode or WT ob a plus modes, Python creates a new empty file before writing. In read mode, a file not found error is raised because the file must already exist. How to overwrite a specific line in a text file. Text files are not random access editable. You must read the whole file, modify the desired line in memory, and write the entire content back, usually with W mode. Example: open notes.txt for reading, read all lines, replace the fourth line with the string updated line followed by a new line, then open notes.txt for writing and write all lines back. Difference between O and a plus. O is write only, the pointer is at the end and you cannot read. A plus is read write, the pointer starts at the end and you can seek back to read existing data. Will W truncate the file before writing? Yes. As soon as the file is opened, its size becomes 0 and any previous content is lost. How to ensure data is physically stored on disk. Call flush on the file object, then call os.fsync with the file descriptor obtained by fileno. Write a program that generates the multiplication table for numbers 1 through 10 and appends it to a file named tables.txt. Then generate the factorials of 1 through 10 and append them as a separate section. Finally, read back the file and verify that each line matches the expected mathematical expression. Solution outline. Step 1. Open tables.txt and append text mode A. Step 2. For each I from 1 to 10, create a line saying I times j equals result newline for all j from 1 to 10, and write it using write or writelines. Step 3. Write a blank line and a header factorials newline. Step 4. Compute factorials using math.factorial of k or an iterative loop, and append lines saying k factorial equals value newline. Step 5. Close the file or use with. Step 6. Reopen the file in read mode, read all lines and compare each line to the expected string. Report any mismatch. Mathematical expressions. Multiplication table entry. I times j equals ij, where I and j are in the set from 1 to 10. Factorial, k factorial equals the product from n equals 1 to k of n, for k in the set from 1 to 10. The program demonstrates writing with append mode, appending new sections, handling newline characters consistently, and finally verifying that the mathematical output is exactly what was intended. This example ties together all the concepts: opening modes, write versus write lines, buffering with the with block, and error-free file handling.